In this lesson, you will learn what sensors are, why their readings are often analog, how an ADC converts data, how feedback systems work, and where common sensors are used. What is a sensor? A sensor is an input device that measures a physical property and sends data to a computer. Sensors can measure temperature, pressure, humidity, light, movement, distance, and many other values. Analog and digital data. Many physical values change continuously. Temperature is one example, so sensor readings are often analog. Computers store and process digital data which uses separate values such as binary numbers. Why an ADC is needed? ADC stands for analog-to-digital converter. It changes an analog sensor reading into a digital value that a computer can understand, store, and process. Sensors in control systems. A sensor measures the current condition and sends the reading to a microprocessor. The processor decides what action is needed and controls an actuator. The sensor then measures the new result. This repeated process is called feedback. Common sensor groups. Sensors can be grouped by what they detect. Environmental sensors measure conditions such as temperature and light. Detection sensors identify objects or radiation. Other sensors measure pressure, sound, chemicals, movement, flow, or level. Environmental sensors. Temperature sensors are used in heating systems and greenhouses. Moisture sensors measure water in soil or materials. Humidity sensors measure water vapor in the air. Light sensors measure brightness and can control street lights or car headlights. Infrared sensors. Active infrared sensors send an invisible beam to a detector. If the beam is broken, the reading changes. Passive infrared sensors detect heat radiation given off by objects or people. They are commonly used in security systems. Other important sensors. Pressure sensors can be used in weighbridges or reactors. Sound sensors convert sound into electrical signals. Gas sensors detect gases such as oxygen or carbon dioxide. pH sensors measure acidity. Magnetic field sensors detect changes in magnetic fields. Movement and level sensors. Accelerometers measure acceleration and changes in velocity. Proximity sensors detect nearby objects. Flow rate sensors measure moving liquids or gases. Level sensors measure the height or quantity of a liquid or material. Temperature control example. In a central heating system, the sensor measures room temperature and sends it to the microprocessor. If the room is too cold, the heating is switched on. When the target temperature is reached, it is switched off. Why sensors matter? Sensors are used in street lights, cars, greenhouses, smartphones, factories, medical equipment, and security systems. Each application uses a sensor suited to the physical property being measured. Exam mistakes. Remember that a sensor is an input device. Sensor data is often analog before conversion. Do not confuse active infrared with passive infrared. Always give a sensible application and mention the ADC when analog data must enter a computer system. Summary. Sensors measure physical properties. Many produce analog data which an ADC converts into digital data. Sensors support feedback and control systems, and different sensors are chosen for different applications. Thank you for watching. Like and subscribe for more IGCSE Computer Science revision. Visit www.tuitionharbor.com or email hello@tuitionharbor.co.uk.